All right, guys, we're going to go ahead and continue on to experiment 5 here. Experiment 5 is a series circuit with potentiometer and resistance R2 and R3. So what I'm going to do here first, I'm just going to mention, we will discuss a little more how each component works in a different video. The potentiometer kind of complicates things a little bit, but I'm going to demonstrate today how we measure the resistance values of the potentiometer. So we're going to go ahead and step 1, of course, you're going to draw the circuit on your worksheet. I'll demonstrate that here. We're going to use our multimeter and measure the value of RH, R2, and R3. So RH shows a minimum and maximum. So what we need to do is we're going to look at our potentiometer. There's a knob here that will adjust the resistance value. We'll turn our board on. And I'm going to turn my meter to 200 ohms. And the way this works is it's a resistor. This is the variable part. So when I turn the knob, the resistance changes at this middle port. So what I'm going to do is I'm going to put my test probes in. Okay, turn it all the way to one side. So my minimum resistance is 1.4 ohms. Okay, so as I rotate this knob, it goes larger than 200 ohms. Okay, so now we're at 500 ohms, and I'll keep rotating it. And then it goes larger than 2,000, so I'll go to 20,000 scale. So there's 2,300, 3,000, 4,400. So we're 4,950 ohms using the 20K ohm scale. Okay, so this resistor goes from 4,950 ohms down to 1.5 ohms. So that is the maximum value of RH is 4,950. The minimum value RH is 1.5 ohms. We're going to go ahead and move on to measure R2. R2 will jump back down to our 200 ohm scale. And again, we're going to measure the resistance of R2. You'll notice when I'm measuring the resistance of components, I don't have any wires connected to it. When we have wires connected to the component, we can accidentally measure a different part of the circuit. So you want to make sure that the component that you are measuring has been isolated from the circuit. R2 is showing us 9.9 ohms, okay? R3, we're going to go ahead and jump to R3, measure the value of R3. R3 is showing us 20 ohms, okay? So R2 was 9.9, R3 is 20 ohms. All right, so the next step here is we're going to wire up the circuit board. So I'll demonstrate how we do that. So we're building a series circuit using the potentiometer. So we want to go ahead and turn that off to protect our circuit. The way this potentiometer works is I'm going to create the potentiometer will have its own circuit, but then I'm going to pull power from this third port. And I'm going to run that from the potentiometer to R3. And because this is a series circuit, it's one continuous path. I'm going to go from R3 to R2. And then I'm going to complete the circuit from R2 to ground. Okay? So now I'm going to measure the total resistance of the circuit. So to measure the total resistance of the circuit, I would essentially measure from the outside of all of my resistors. And I know that I'm going to need the 20,000 ohm scale because it's going to be greater than the total resistance for the potentiometer. So our maximum resistance, let's see here. Having trouble here. Give me 1 sec. So we got total resistance of the circuit. I had voltage on the circuit. So here we go. So when I disconnect my ground wire, now I'm able to measure it. So see that? When I had the circuit connected, the meter was trying to measure something that's not what we're trying to measure. So we're going to go ahead. So we got 40,000, 50,000. So the scale goes higher. Huh. I might have a connection issue. Bear with me 1 minute. Okay, so I found that I just had a bad connection on my meter. I went ahead and completely removed the ground wire from R2. The rest of the circuit is connected the same. So what I've done here, and I disconnected my power wire from the potentiometer. So I'm going from the front of the potentiometer to the end of R2. So I followed my path all the way across the circuit. So it's before the first resistor and after the last resistor is what I'm measuring. So what you'll see is I'm on the 20,000 ohm scale. So right now I'm measuring 20 ohms as the minimum. So our total resistance minimum is 20 ohms. As I rotate my knob, you'll see the resistance climb 2,000, 3,000, 4,000, 5,000. So it jumped back down to 4,000. So when I have that knob turned all the way to the end, our total resistance maximum is 4,980 ohms. Okay, 4,980 ohms. Now that we know the amps, now that we know the resistance, we measured the resistance, we're going to calculate the amps. So you're going to take a minute, you're going to calculate the amps, you'll punch in that number, and you'll be able to use your voltage as source voltage, in this case which is 10.2 volts. So you'd use the resistance values that you just measured, use the voltage available at the board, and you can use Ohm's law to identify the minimum amperage and the maximum amperage moving through the circuit. Now, move this out of the way. Let me complete my circuit one more time. Because on step 8, it's asking us to measure the voltage drop for each resistor. So voltage drop is simply when we're measuring across the component, we're measuring the voltage that one specific component is using. So in experiment 5, the first one here is voltage R2 minimum, voltage R3 minimum, and then voltage R2 max, voltage R3 max. If I'm going too fast, that's okay. You can watch this video as many times as you need. I'm going to go ahead and spend some more time discussing this in class as well. So we're going to start where our minimum voltage for R2. So in our current setting, our voltage shows 0. Okay, so we have 0 volts as our minimum, and then our maximum volts for R2. Oh, I got to use the 20 volt scale. Is 3.25 volts. Okay, so our minimum volts was 0 for R2, and our maximum volts was 3.25. Okay. I'm going to jump to R3, and this is voltage drop across R3. It looks like my maximum volts for R3 is 6.52 volts, and my minimum volts for R3 will be 0. So the idea of this activity is to show you that in a series circuit, the current will stay the same, the amps will stay the same on the minimum side, and then when you go to the maximum, the amps will stay the same. And by using Ohm's law, you can prove that the current is the same, the resistance is the same, but the voltage will change according to your potentiometer adjustment. So that'll wrap up experiment number 5. If you have any questions, please email me or see me during the Zoom session, and we will discuss and clarify. Thanks.